Steam distillation is particularly used for separating temperature-sensitive substances. Steam distillation is based on the volatility difference of the individual components of a mixture. When two immiscible liquids are heated and agitated together, surface of each liquid exerts its vapor pressure as if the other component of the mixture is absent. This process leads to a significant increase in vapor pressure within the system, which will allow compound with low boiling points to evaporate with water. And this vapor pressure continues to increase when vapor pressure of these liquids outpaces atmosphere pressure. Two immiscible liquids start to boil. Through these elements with high boiling points evaporate at lower temperatures, forming a mixture with water. Many organic compounds are insoluble in water. Therefore, at an absolute temperature, we can purify material below the point where it decomposes. Steam distillation is very successful when the boiling point of the substance to be extracted is higher than the boiling point of water. Steam distillation is particularly useful for extracting temperature-sensitive substances like essential oil from plant materials. Essential oil has a low boiling point which can evaporate at lower temperatures by forming mixtures with water. In this process, steam passes through plant material that contains oil, rupturing the structures and releasing the volatile and unvolatile compounds. The resulting vapor is a mixture of steam and oil condenses, which will form two distinct layers, water and essential oil. Then the condensed mixture is collected and allowed to settle. These two layers can be separated using a separatory funnel. Today, we are going to extract essential oil from cinnamon. Those are the instruments that we will be using for this experiment. Tripod, wire mesh, two rubber tubes, two stands, a round bottom flask, cinnamon, a conical flask, condenser, clamps, and Bunsen burner. First, we filled the round bottom flask with cinnamon and added water just to cover the cinnamon. Then, the round bottom flask was placed on top of a tripod and wire mesh to enable the steam to flow through. Here's the full view of our apparatus. In here, it is important to make sure that the bottom of the round bottom flask is touching the wire mesh. Then, a condenser is connected to the round bottom flask and two rubber tubes are attached to the condenser to let water in and out. Other end of the rubber tube connected with water in is then connected to a tap. Then, from the other end of the condenser, a mixture of oil, condensers and water is collected to a receiving flask, to which we use a conical flask here. We have sealed the whole system using grease. Then we can turn on the Bunsen burner and let the water inside the round bottom glass boil, and at the same time we also turn on the tap to let water in. Here you can see steam collecting inside the condenser due to evaporation of organic compound mixture and a mixture of oil condensed, which is cinnamaldehyde, and water collecting into the conical flask. Now we are done with the extraction, and here you can see our essential oil extract. At this point, we have a mixture of water and oil in this flask. To facilitate the separation of oil and water, we add 1 scoop of sodium chloride to the collected distillate. Sodium chloride helps to salt out the oil, making it easier to separate the organic phase from the aqueous phase. Next, we measure out 10 milliliters of dichloromethane using a measuring cylinder. Dichloromethane is an excellent organic solvent that will help in extracting the essential oil from the aqueous phase. Then we pour the distillate and the 10 milliliters of dichloromethane into a clean and dry separatory funnel. Make sure to cap the funnel tightly, hold the funnel horizontally and shake it well. This vigorous shaking allows the dichloromethane to effectively dissolve the essential oil. While doing this, you must occasionally open the bottom tap to release any built up gas pressure. After shaking, place the separatory funnel on a ring clamp and allow it to rest. So the layers can separate. Slowly open the tap to release the organic layer into a clean Erlenmeyer flask. Keep the aqueous layer in the separatory funnel. To ensure maximum extraction, we can repeat the process. Add another 10 milliliters of dichloromethane to the aqueous layer in the separatory funnel. Shake well and separate the layers again. Combining the newly separated organic layer with the previously collected organic extract in the Erlenmeyer flask. To remove any remaining water from the organic extract, we add anhydrous magnesium sulfate until some of the salt swirls freely, indicating that it has absorbed as much water as possible. Then we prepare a funnel by plugging it with a small piece of clean cotton. Next, take a clean evaporating dish and tie it using an analytical balance. Measure its weight when empty and record the value. Hold the funnel with a ring clamp over a clean evaporating dish. Carefully pour the organic extract to the cotton plug in small portions. The cotton will filter out the magnesium sulfate and any other particulates, leaving a clear organic solution of essential oil. Collect the filtrate in the tiered evaporating dish. Check the weight again and note it down. After getting these two values, it is easy to know the initial mass of the collected solution. Place the evaporating dish in a water bath set to 45.3 degrees Celsius. The general heat from the water bath will slowly evaporate the dichloromethane, leaving behind the essential oil. Ensure the temperature is maintained at 45.3 degrees Celsius to prevent the degradation of the essential oil. Once the solvent has fully evaporated, measure the weight of the evaporating dish with the evaporated mixture. The difference in weight before and after evaporation gives the mass of the extracted cinnamon oil. Finally, transfer the extracted cinnamon oil to a clean vial. Label the vial appropriately with details such as the type of oil, date of extraction, and name of the group members.